In a groundbreaking announcement that could redefine our place in the cosmos, NASA has reported the detection of the first-ever alien signal, emanating from the direction of Proxima b, the closest known exoplanet to Earth, situated just over 4 light-years away in the habitable zone of its star, Proxima Centauri. This discovery sends waves of excitement and curiosity across the globe. Could this be the moment humanity learns it is not alone in the universe? The journey to this momentous discovery began with meticulous observation by NASA's powerful telescopes, which have been monitoring distant stars and planets in search of signs of life. Proxima b has always been a prime candidate in the search for extraterrestrial intelligence, due to its Earth-like qualities and proximity to our solar system. The detected signal, distinct, patterned, and unlike anything astronomers have observed before, marks a potential turning point in human history. The implications of such a discovery are profound. Firstly, it confirms the long-held scientific hypothesis that life could exist on other planets in conditions similar to those on Earth. Secondly, and perhaps more intriguingly, it poses the question of the nature of the civilizations that might reside there. Are they merely microorganisms, or are they advanced beings possibly capable of communication and interstellar travel? This signal from Proxima b is not just a series of random noise or natural cosmic phenomena. It carries a structured repetition that suggests an intelligent origin. NASA scientists, along with international teams, are now tasked with deciphering this message, attempting to understand its content and the intentions behind it. The global scientific community is abuzz with theories and speculations on what the message might contain: guidance, a greeting, a warning, or something entirely unimaginable. The news of this discovery has transcended scientific circles, sparking discussions on social media, in government halls, and at dinner tables around the world. People are looking up at the stars with a renewed awe and wonder, pondering about the beings that might be doing the same in a distant world. How similar or different could their world be to ours? What could their society, technology, and culture look like? The possibilities are as vast as the universe itself. Moreover, this detection opens a Pandora's box of ethical and existential questions. How should humanity respond if the signal's originators are indeed attempting to communicate? What protocols should be established for interstellar diplomacy? And most importantly, how will such a discovery change our understanding of life, religion, and our very identity as human beings? While the excitement is palpable, caution remains at the forefront. NASA, along with other space agencies, is diligently working to validate the findings, ensuring that the signal is not a false positive or a misinterpretation. As we stand on the precipice of potentially the most significant discovery in human history, the next steps must be taken with precision and responsibility. As the world waits with bated breath for further analysis, the detection of an alien signal from Proxima b not only propels our scientific endeavors into a new era, but also unites us with a shared curiosity and a collective hope that we might finally be on the verge of answering one of humanity's oldest and most profound questions. Are we alone in the universe? In April 2019, a radio signal was detected which had come from outer space. The source of it? The region of Proxima Centauri, 437 light-years away from us. While it may seem far, the next sun-like star is 3 times away from us. The third brightest star in our sky. It comes from a triple star system consisting of the binary star pair Alpha Centauri A and B and Alpha Centauri C, or Proxima Centauri. Alpha Centauri A and B, the 2 stellar companions, are relatively close to each other. Both stars are quite similar to the Sun. Alpha Centauri A shines with yellow light and is 1.5 times brighter than the Sun, while Alpha Centauri B is half as bright with an orange hue. Alpha Centauri A is a little bigger than our Sun, and Alpha Centauri B is smaller. So our Sun fits exactly right between them. The pair is also older than the Sun, with an age of 5 billion years. But where among the stars did the signal come from? And from what? Discovered by the Breakthrough Listen project, the signal has been dubbed as Breakthrough Listen Candidate 1, or BLC-1. The project was established to seek extraterrestrial communication in the universe by intelligent organisms. Garnering roughly $100 million in financing, the project has dedicated thousands of hours of telescope observation time from around the world while using cutting-edge facilities. The signal was detected by the CSIRO Parkes Radio Telescope in New South Wales, Australia. The telescope, as usual, was observing the region of the nearest star to our Sun, Proxima Centauri, and it almost went undetected among the large volumes of data collected over the time of thousands of hours. But the scientists discovered it like a needle in the hay. For the signal to be considered, it needs to have two definite traits first. It has to be limited to a small band of frequencies, just like radio. As such, signals are unusual, as no natural mechanism in space can create such a signal. The second property, it should consist of a frequency that fluctuates according to the analogous motion of the exoplanet relative to Earth. The scientists had to go through nearly 4 million individual signals picked up by the telescope in Australia, and after much sifting and discarding of unnecessary signals, they were able to find 5,000 distinct ones. And among them was the chosen one, a single signal which could not be explained after cross-checking with contemporary radio transmitters on Earth. It was one-of-a-kind techno-signature with narrow broadband that came only when the telescope was pointing towards Proxima Centauri and appeared over 30-hour observation period. And on deep diving, the derived location turned out to be Proxima b, discovered by astronomers in 2016 by using the radial velocity method, where a star doesn't remain completely stationary when it's being orbited by planets. Due to the gravitational tug of the small planets, the star will move in a small little circle. Extremely sensitive spectrographs are used by researchers to track a star's light spectrum. The star's light appears a little blue shifted when there is a planet around it, and a little red shifted when it moves away from the planet. When these shifts are repeated after a fixed number of days, months, and years at regular intervals, then it is accepted that the shifting of light is definitely caused by the to and fro tugging done by a planetary body orbiting around the star. Upon closer inspection, Proxima b turns out to be identical to Earth. The exoplanet seems to have a radius of 1.1 Earths and a mass of 1.3 times our planet with an equivalent density. It's a rocky world. There are differences too. First is the location of the two planets in their solar system. Proxima b is much closer to its parent star, located only 0.05 astronomical units away from it. Even Mercury is at a distance of 0.04 astronomical units, making Proxima b closer to its star. With such distance, the planet should be a fiery hell just like Mercury, correct? But Proxima Centauri is a faint red dwarf, and just like Earth, it receives 60% energy from its star, making the planet orbit in the habitable zone, and this means life could potentially exist there. There are countless numbers of unknown planets scattered across our universe. We have already discovered an astonishing 4,935 exoplanets, and recently, we came across 65 new planets that has taken our tally to 5,000. The latest batch of 65 exoplanets, planets outside our immediate solar system, were added to the NASA Exoplanet Archive on March 21st this year, marking the start of the planetary odometer. The JWST is the most advanced telescope ever made, and it is 100 times more powerful than its predecessor. With its help, we can unravel the secrets of this boundless expanse. In the past, we have discovered all kinds of planets, small, rocky worlds, gas giants larger than Jupiter, and extremely hot inhabitable planets. Out of all of these, there are a few planets that stand out. Kepler 1649c is one such planet. Its characteristics are very similar to Earth. In fact, this is the most habitable planet that we have discovered that may shelter life. Till now, we have been able to find 55 of these Earth-like planets, but not yet been able to study all. With the rate at which our technology is advancing, and mostly because of the James Webb, who knows what we might be capable of in the future? Wouldn't it be amazing to come across a planet that can sustain life? One of Webb's primary goals during its first year of science missions is to find and study extraterrestrial worlds beyond our solar systems, with a focus on how they form, as well as the possibility of them having water and biological life. Webb's research into star and planet formation allows us to link studies of mature exoplanets to their birth conditions, as well as our own solar system to its origins. Webb's infrared capabilities are perfect for revealing how stars and planets are formed for three particular reasons. Infrared light penetrates dust well, takes up the thermal signatures of young stars and planets, and indicates the presence of key chemical constituents, like water and organic chemistry. Mid-infrared light may pass through clouds that are 20 times thicker than visible light. This is especially important when looking at newborn stars that are concealed inside their natal clouds. As these clouds haven't dispersed for these young stars yet, we can't see visible light. Webb's infrared capabilities are crucial because they allow us to see, investigate, and grasp the early stages of star formation when gas and dust are still squeezing inwards to give birth to young stars. But there's more to natal star clouds than that. Young stars and giant planets both start off as huge, puffy structures that gradually contract over time. While newborn stars become hotter as they grow older, the giant planets become colder, but they both emit more light in the infrared than visible wavelengths. That means Webb will excel at finding new stars and planets and can aid in our understanding of the physics of their formation. MIRI will also look for heated molecular gas near numerous young stars, which could indicate the formation of rocky, potentially habitable planets. It's no wonder that a large portion of Webb's early scientific work focuses on determining how planetary systems construct molecules. That may be crucial for the advent of life as we know it.